Biomes are large geographical regions of Earth which have characteristics types of biotic communities adapted to the climate of the region. The climate, geography, and soil of a region determine what type of biome can exist in that region, which are defined without reference to plant species composition. Moncrief et al. 2016. The biomes have developed over long periods of time, during which the distribution of land masses, ocean basins and climate zones have changed continually. Climate has a major regulatory effect on the evolution of flora and fauna, which in turn affect the characteristics type of vegetation with marked differences in growth form, leaf morphology and seasonality of foliage. Major biomes include deserts, forests, grasslands, and tundra, and several types of aquatic environments. There are different ways of classifying biomes, but the common elements are climate, habitat, animal and plant adaptation, biodiversity and human activity. Each biome consists of many ecosystems whose communities have adapted to the small differences in climate and the environment inside the biome. While discussing various concerns with the biome concept, Moncrief et al. 2016 have stated that biomes are still useful organizing principles for describing the functioning of the world's ecosystems and the role of these ecosystems for Earth system function. 21.2. Biome concepts. Alexander van Humboldt in his pioneering work on plant geography found a close relationship between climate and vegetation in geographically disjunct regions, exhibiting climatic similarity in similar regions. Van Humboldt 1807. Alexander van Humboldt was a German explorer and naturalist. With his book Cosmos, he made a valuable contribution to the popularization of science. The biome concept as developed by Schimper 1903, is based on the idea that similar climates select for similar plant forms independent of differences in history. An overview of some biome concepts is briefly presented in Table 21.1 to give an idea of different ways of classifying biomes. In many early biome concepts, climate parameters were clearly incorporated into the definition of a biome. Table 21.1. Holdridge 1947 produced a systematic scheme of life zones describing large vegetation formations based on three climatic factors, i.e., biotemperature, mean annual precipitation, and 5. Ecosystem structures and functions. Potential evapotranspiration ratio. He gave a detailed classification of different biomes in terms of both physiognomy and climate. Holdridge, 1967. Similarly, Walter 1973 defined biomes in terms of the climate zone they occupy, i.e., zonobiomes. Schultz 2002 recognized 9 ecozones, which represent large regions of the geosphere, where physical factors such as climate, soils, landforms and rocks interact to provide a medium for the growth of plant life, and a habitat for animal life. The various early and contemporary biome concepts and maps recognize lower hierarchical levels of vegetation formations below global biomes, which are generally defined with reference to geographical context. Biomes have been defined traditionally on the basis of plant physiognomy and geographical distribution or climate. Remote sensing of land cover with satellite and a climatic database provide an opportunity to map biomes with exact boundaries. Roy et al. 2006, Areno et al. 2007, and with objective definition of biomes. Woodward et al. 2004. The MODIS land cover type product uses the IGBP classification schema in which vegetation is classified into 17 classes. A global representative analysis for terrestrial conservation was carried out by Dasman 1974 and Udvardy 1975. Dasman's system recognized 198 biotic provinces, whereas Udvardy's took into account 193 units nested within 7 biogeographic realms and 13 terrestrial biomes and 1 freshwater biome. Both these geographic models served as basis for recognizing terrestrial ecoregions. Olson et al. 2001. A biogeographical realm is the region that shares species with similar biogeographic history. A biogeographical realm is the region that shares species with similar biogeographic history. Terrestrial ecoregions of the world is a biogeographic regionalization of the Earth's terrestrial biodiversity, which are called biogeographic units or ecoregions. Olson et al. 2001. Ecoregions represent broad habitat and vegetation types and span across biogeographic realms. For example, the tundra biome is found in both Palearctic and Nearctic realms. The boundaries of an ecoregion approximate the original extent of natural communities prior to major land use change. Ecoregions are useful units for assessing global biodiversity and ecosystem services. MA 2005. The Earth's most 6. Ecosystem structures and functions. Biologically outstanding terrestrial, freshwater and marine habitats have been designated as ecoregions. Table 21.1 An overview of some biome concepts from early studies to the present based on Moncrief et al. 2016, Higgins et al. 2016. Biome concept term based on mapping variables. Actual or potential vegetation hierarchical. Reference. Walter Zonobiome Climate Potential Yes Walter 1973. Schultz Ecozone Climate Potential Yes Schultz 2002. Holdridge Life Zones Climate Biotemperature, Mean Annual Precipitation, and per Actual Holdridge 1967. WWF Biome Ecoregions. Climate, Structure, Orography Climate, Soils, Expert. Knowledge, Structure Potential Yes Olson et al. 2001. Modus IGBP. Land Cover Structure, Function. Human Influence. Spectral. Reflectance, Temperature, Topography, Snow, Ice. Actual No Friedel et al. 2002, 2010. Functional Biomes. Biome Structure, Function. Vegetation Productivity Index. The minimum of vegetation. Activity, Plant Height. Actual number. Higgins et al. 2016. Per equals potential evapotranspiration ratio. 7. Ecosystem structures and functions. 21. 3. Biome classification. The different schemes of biome classification commonly used are briefly described as follows. 21.3.1 Walter's Zonobiome. The land biomes of the world are controlled by climate. Climate is the characteristic condition of the atmosphere near the Earth's surface at a certain place on Earth. It is the long-term weather of that area, at least 30 years. This includes the region's general pattern of weather conditions, seasons and weather extremes like hurricanes, droughts, or rainy periods. Two of the most important factors determining an area's climate are air temperature and precipitation. Figure 21.1. Generally, plants need about 20 millimeters of monthly precipitation for every 10 OC so that the precipitation scale interval is twice the temperature scale. Generally, plants need about 20 millimeters of monthly precipitation for every 10 OC so that the precipitation scale interval is twice the temperature scale. The temperature and precipitation lines define periods of water deficit and water abundance. When the precipitation line is above the temperature line, precipitation is plentiful and temperature is the main determinant of plant growth. At higher temperatures, plants require more water. As an example, the climatic diagram for a semi-arid region supporting thornwood vegetation for Jaipur, India is shown in Figure 21.2. Figure 21.1. Walter's climate diagram, adapted from Rickliff's, 2000. 8. Ecosystem structures and functions. Fig. 21.2. Climate diagram for Jaipur, India, A. Station, B. Height above sea level, C. Number of observations. Fig. 21.2. Climate diagram for Jaipur, India, A. Station, B. Height above sea level, C. Number of observations of temperature and precipitation, D. Mean annual temperature, AOC, E. Mean annual precipitation, based on Walter 1979, adapted from Singh et al. 2015. The world contains a great diversity of biomes because its climate varies so much from place to place. The 9 climate zones, termed zonobiomes, ZB, are given in Table 21.2. Walter's scheme is based on precipitation and temperature stress on the dominant plants. Climate diagrams are useful in encapsulating major climate features for each biome. The moisture and temperature curves are depicted by month, and shows relative moisture deficit or surplus. Biomes correspond closely to major climate zones. Geographic distribution of terrestrial biomes corresponds closely to major climate zones. 9. Ecosystem structures and functions. Table 21. 2. Climate and major terrestrial biomes based on Walter, 1979. Zonobiomes, climatic zones, biomes. ZBI equatorial high temperature and high rainfall, tropical rainforest, ZB2 tropical high temperature and seasonal. Drought. Tropical seasonal forest, savanna. ZB3 subtropical high seasonal arid climate, subtropical desert, ZBIB Mediterranean winter rainfall and summer. Drought. Woodland, shrubland. ZBV warm temperate cool winter and warm summers. Temperate evergreen forest. ZBV Nemoral moderate climate with winter freezing. Temperate deciduous forest, frost resistant. ZB7 continental, arid temperate with cold winters. Temperate grassland, cold deserts. ZB8 boreal, cold temperate, cool summers and long winter. Evergreen boreal coniferous forest. Taiga. ZB Expolarvery, cold winters, Arctic tundra, alpine tundra. 21.3.2 Whitaker Biome Classifications. In his seminal work, Whitaker, 1975, combined the vegetation types and climate parameters, mean annual temperature and precipitation, into a scheme of biome distribution. Fig. 21.3. The pattern of major world biomes have been depicted in two-dimensional coordination system composed of mean annual precipitation and mean annual temperature, and identifying 4 major ecoclimes. The biomes with respect to climatic factors represented warm-moist, warm-dry and cool-dry conditions. In the 10. Ecosystem structures and functions. Temperature range of 20 to 30 OC. Vegetation types range from rainforests to deserts depending upon the amount of rainfall. Figure 21.3. Seasonal forests, short dry forests and scrublands have been distinguished in the range of 250 to 150 millimeters annual rainfall. In the temperate latitude, the vegetation has been distinguished into 4 types: temperate rainforests, temperate seasonal forests, woodland and shrubland, and cold deserts along the gradient of decreasing rainfall. In the cold climate, i.e., taiga region, the vegetation types are not distributed on the basis of climate. At temperatures below 50 C, all the vegetation types are classified as tundra. Fig.21.3. The pattern of major world biomes depicted in two-dimensional coordination system composed of mean annual precipitation and mean annual temperature based on Whittaker 1975. 21. 3.3 Holdridge Life Zone Classification. Holdridge 1967 provided a detailed classification of different biomes in terms of both physiognomy and climate, often known as climate envelopes. Holdridge 1967 based his classification of world life zones or plant formations on the basis of three major climatic factors: heat, precipitation and moisture. Fig.21. 4. In this biome classification scheme, moisture is considered to be dependent upon heat and 11. Ecosystem structures and functions. Precipitation. Each life zone refers to a certain type of plant association and also to the ranges of values of temperature and precipitation which produces this association. The life zone classification was one of the first attempts towards biome mapping by providing a complete description of life zone distribution defined by robust bioclimatic variables. The Holdridge system is applied globally to assess the sensitivity of global vegetation distribution to climate change. The study used 90 different plant types and bioclimatic envelopes, lower and upper boundaries, for 8 bioclimatic indices using available climatic normals. He defined 39 life zones based on 3 climatic parameters viz. Biotemperature Pt, mean annual precipitation P, and potential evapotranspiration ratio per. Potential evapotranspiration is the amount of evaporation that would occur if water were not limited. Annual precipitation is rain or snow. Figure 21.4. Holdridge classification of world life zones, from Holdridge 1967, adapted from Singh et al. 2015. 12. Ecosystem structures and functions. 21. 3.4 The IGBP DIS Lands Cover Classification System International. Biomes are areas of vegetation that are characterized by the same life form. The traditional classification of biomes shows sharp boundaries between biomes, whereas in reality, the majority of biomes exhibit often wide transition between adjacent biomes. Woodward et al. 2004. International Geosphere Biosphere Program Data and Information System IGBP DIS classification defines forests in the transitional zones between biomes as mixed forest, so the transitional zones are in effect considered as biomes. Using geospatial tools, 17 biomes have been recognized. The IGBP DIS has derived such a classification of biomes in which geographical location plays no part. Tree-dominated biomes are defined as forests when tree cover exceeds 2 meters in height and constitutes more than 60% of the canopy cover. 5 major tree biomes can be recognized by satellites based on leaf longevity and morphology: needle-leaf evergreen, broadleaf, needle-leaf deciduous, broadleaf cold deciduous and broadleaf drought deciduous. Observations indicate that broadleaf drought deciduous vegetation grades substantially into broadleaf evergreen vegetation. The needle-leaf deciduous biome occurs in the world's coldest climates. 21. 3.5 Udvardy's biogeographical realms and provinces. Biogeography is the study of past and present-day spatial distributions of both flora and fauna on Earth in relation to environmental factors such as geology, climate and soils. The floristic and biogeographic realms are now known as biotic provinces, which include all life forms including plants, invertebrates and vertebrates. Udvardy, 1975. This system is a combination of two approaches, i.e., physiognomic and biogeographic. Udvardy, 1975. The physical structure of the dominant vegetation and the distinctive flora and fauna compositions defines the boundaries. The ecoregions are classified within a system comprised of biogeographic realms and biomes. The hierarchy of the Udvardy scheme is as follows. I. Biogeographic realm equals biogeographic regions and subregions with 8 categories. 13. Ecosystem structures and functions. E. Biogeographic province equals biotic province with 193 categories, each characterized by a major biome or biome complex. E. Biome, with 14 types. This classification has been used for biogeographical and conservation purposes. Biome types according to Udvardy, 1975, are given in Table 21.3. 21. 4. Terrestrial ecoregions of the world. Olson et al. 2001 have subdivided the terrestrial world into 14 biomes such as forests, grasslands, or deserts and 8 biogeographic realms. Nested within 14 biomes are 867 ecoregions. Ecoregions, representing distinct biotas, are nested within the biomes and realms. Ecoregions represent broad habitat and vegetation types and span across biogeographic realms. For example, the tundra biome is found in both Palearctic and Nearctic realms. The boundaries of an ecoregion approximate the original extent of natural communities prior to major land use change. The nested classification levels provide a framework for comparison among units and the identification of representative habitats and species assemblages. Olson et al. 2001. Biome types. Udvardy, 1975, and the biomes for delineating ecoregions based in Olson et al. 2001 are given in Table 3. Table 21. 3. Biome types Udvardy, 1975, and biomes major habitat type based on Olson et al., 2001, and WWF. Biome types Udvardy, 1975, biomes Olson et al., 2001. 1. Tropical humid forests. 1. Tropical and subtropical moist broadleaf forests. 2. Subtropical and temperate rain forests or woodlands. 2. Tropical and subtropical dry broadleaf forests. 3. Temperate needle-leaf forests or woodlands. 3. Tropical and subtropical coniferous forests. 4. Tropical dry or deciduous forests. 4. Temperate broadleaf and mixed forests. 14. Ecosystem structures and functions. Incal, monsoon forests or woodlands. 5. Temperate broadleaf forests or woodlands, and subpolar deciduous thickets. 5. Temperate coniferous forest. 6. Evergreen sclerophyllous forests. Scrubs or woodlands. 6. Boreal forests. Taiga. 7. Warm deserts and semi-deserts. 7. Tropical and subtropical grasslands, savannas and shrublands. 8. Cold winter continental deserts and semi-deserts. 8. Temperate grasslands, savannas and shrublands. 9. Tropical grasslands and savannas. 9. Flooded grasslands and savannas. 10. Tundra communities and barren Arctic desert. 10. Montane grasslands and shrublands. 11. Temperate grasslands. 11. Tundra. 12. Mixed mountain and highland systems with complex zonation. 12. Mediterranean forests, woodlands and scrubs. 13. Mixed island systems. 13. Deserts and xeric shrublands. 14. Lake systems. 14. Mangroves. 21. 5. Freshwater and marine ecoregions of the world. The map of freshwater ecoregions is based on the distributions and compositions of freshwater fish species as well as in incorporating major ecological and evolutionary patterns. Abel et al. 2008. These ecoregions can serve as a useful tool for global and regional conservation planning efforts. 4. 15. Ecosystem structures and functions. Serving as a logical framework for large-scale conservation strategies, and for providing a global-scale knowledge base for increasing freshwater biogeographic information. The map of freshwater ecoregions contains 426 units, covering nearly all non-marine parts of the Earth, exclusive of Antarctica, Greenland, and some small islands. There is large variation in the area of individual ecoregions. Spalding et al. 2007 proposed marine ecoregions covering all coastal and shelf waters of the world. Marine ecoregions of the world is a nested system of 12 realms, 62 provinces, and 232 ecoregions. The Marine Ecoregions of World classification provides a critical tool for marine conservation planning and a rational framework to analyze patterns and processes in coastal and shelf biodiversity. 21. 6. Functional classification of biomes. Recently, Higgins et al. 2016 have classified biomes based on 3 functional attributes of vegetation, i.e., IA Vegetation Productivity Index (VPI), based on the Normalized Difference Vegetation Index (NDVI), whether the minimum of vegetation activity is in the driest or coldest part of the year, vegetation height estimated from satellite data. The first and second functional attributes give information about the extent to which vegetation activity in the unfavorable part of the year is limited by temperature, by moisture, or by both. This new biome classification scheme can be used for synthesizing data of the biogeochemical rates of terrestrial ecosystems as well as to analyze patterns of biome change observed over recent decades. The findings and method of the study provide a new source of data for monitoring global vegetation change, analyzing drivers of vegetation change and for benchmarking models of terrestrial ecosystem function. Higgins et al. 2016. 16. Ecosystem structures and functions. 21. 7. Summary. I. Biomes are large geographical regions of Earth which have characteristics types of biotic communities adapted to the climate of the region. Biomes have been defined on the basis of plant physiognomy and climate. There are different ways of classifying biomes, but the common elements are climate, habitat, animal and plant adaptation, biodiversity and human activity. The different schemes of biome classification include climate zone approach, zonobiomes, of Walter, the vegetation approach given by Whitaker, Holdridge life zone classification, and WWF World Wildlife Ecoregions. IV. The 9 climate zones given by Walter, termed zonobiomes, ZB, are based on precipitation and temperature stress on the dominant plants. Geographic distribution of terrestrial biomes corresponds closely to major climate zones. V. The vegetation approach for classifying biomes was given by Whitaker, who combined the vegetation types and climate parameters, mean annual temperature and precipitation, into a scheme of biome distribution. V. Holdridge classification of world life zones or plant formations is based on 3 major climatic factors: heat, precipitation and moisture. V. Using geospatial tools, 1717 biomes have been recognized for the lands cover classification of the IGBP DIS. V. The terrestrial ecoregions are nested within 2 higher order classifications, i.e., biomes 14 and biogeographic realms 8. Ix. WWF World Wildlife defines an ecoregion as a large unit of land or water containing a geographically distinct assemblage of species, natural communities, and environmental conditions. 17. Ecosystem structures and functions. X. The map of freshwater ecoregions is based on the distributions and compositions of freshwater fish species as well as in incorporating major ecological and evolutionary patterns. Marine ecoregions cover all coastal and shelf waters of the world.